Okay, hello. Today I'll be explaining some different kinematical equations that might be useful to you when you're solving kinematical problems. These kinematic equations apply for linear and 2D kinematics. So we'll get started. So basically what we're asking right now is, what is kinematics? Kinematics is known as the study of motion. Okay, so when we're looking at kinematics, we're looking at how things are moving within our universe, okay, within our space and time plane. So right now, I'll make this as simple as possible. We're going to look at a 1D plane, which basically means we have 1D, we only have one axis. We have a point 0, or we can call this x initial, okay, and we have a positive plane and negative plane, and that's basically it. Now, when they refer to 1D kinematics, they're really referring, there is still two dimensions. There's space, the space we have here, and then there's time, right? Time passes and objects move throughout time, which is what we're going to try to measure. So basically, any kinematic problem you're going to have an object and you're going to study its motion. So let's say we have an object, a block, okay? And the block is moving from x initial to final position. It's moving all the way here, okay, and it's going to take it a time, delta t. Delta means a change, so we're looking at a change in time, so 1 second, 2 seconds, okay. So we have a block, it's moving from x initial to f final, and it's taking a certain amount of time to do so. This is as simple as it gets, okay. So let's look at the displacement of this. So this block is being displaced from this x initial to this x final, okay? Now what we don't know is how it's being displaced. So let's make any type of graph, okay? Here we go, we have a graph here, okay, and we have a time, and we'll put that as a displacement axis, okay? You don't have to use t and x to variable your displacement and time. You can use any variable you want. I'm just using these to keep it simple. Okay. So we have our x initial, and let's say our x final is here. So we know the block is starting here at time 0, and it's going to move here at a time final. Okay. And let's say the block maybe 1 second is here. Maybe it moves faster and faster as it gets here. So we'll say that that's our displacement versus time graph, okay? And all we have to do now is try to find an equation that can model this. Now, there isn't really an equation that we can find yet that will model our displacement. What we can do is model the slope, the average slope that this makes. So this does require calculus to find the exact slope, but we don't need calculus. All we want to do is find what is the slope that it takes to get from here to here. So in other words, we're finding the average speed. We're finding this triangle here. Okay, so if you remember from if you're in Canada grade 9 math class, you learned the slope is rise over run. Okay, easy. So rise is the change in x, right? We're going from x initial to x final, so we get change in x over the change in time. Change in time, right? Pretty simple, okay? And now, this line, the slope that we're finding, is what's equal to the speed, okay, or v for velocity, okay? So why does this make sense? Well, because if this is moving from x initial to x final, okay, let's say it's, we're measuring this in meters, okay? And we're moving from x time initial time final second, then our speed is going to be in meters per second, right? Which is the dimension of speed. It's length over time, okay? So how the slope of the line it takes on the displacement graph is equal to the speed, okay? Now, change in x and change in time, we can also say that's equal to x final minus x initial over time final minus time initial, right? Because that's the change. It's the difference between this and this. So in other words, it's a change. Okay, so we'll just put that in a box. Okay, and we'll make another graph. Okay, let's make a graph of time versus speed. Okay. So if we have time and speed, we'll say that since the slope is increasing slightly, we'll say maybe it looks like that. So now, what if we want to find the slope of this line to find the rate of change of the speed, also known as the acceleration? Okay, I'll label it as A. So that's basically how fast is it speeding up. Okay, how fast is the block moving faster and faster. Okay, so this acceleration will be equal to the change in speed over the change in time, right? Rise over run, okay, which is also equal to v final minus v initial over t final minus t initial, okay, and that's the acceleration. Okay, pretty simple so far. So now for most kinematical equations, at least at the basic level, we're gonna say that acceleration is constant, right? That means it can be positive, it can be negative. You can have a value for your acceleration, but it's gonna stay the same. Your acceleration isn't changing, because if it does change, it makes this whole kinematical equations a lot more difficult to solve. It's solvable, but it makes it a lot more difficult. Okay, so you've probably heard so far of the 5 kinematical equations, the big 5, whatever you want to call it. The one thing about this is that we don't really need 5 equations to solve all the kinematical problems, right? So let's work through that. Let's try to derive the 5 equations from we have here, from these basic laws of physics here. So the first equation we can derive from this, that the speed is equal to the change in position over the change in time, right? The first thing that we solved. Okay, now we can rearrange this to say that the change in position is equal to the speed times the time. Now, one thing we have to note is that this is an average speed and this is an average acceleration, right? Because we're not looking at the speed here versus here. The speed here is a lot less than the speed here, right? If we look at our speed graph, this is a lot greater than here. But we're just looking at the average. We're looking at what's the average speed it took to get from here to here. And what do you know about averages? Average is we take our final, we take our initial, we divide it by 2. That's an average, right? Very simple to do. So we can say that change in x is equal to 1/2 of v final plus v initial times the change in time, right? We're just taking that and we're dividing it by 2. There's our first kinematical equation. Okay, second equation. We just do the same, but with our average acceleration. So acceleration is equal to change in velocity over change in time. Okay, now with all these equations, we're going to say that acceleration is constant. So if we take, if acceleration constant, let's say it's 2, so we're taking acceleration initial plus acceleration final, dividing it by 2. So 2 plus 2 over 2 is just 2. Okay, so this is just acceleration equals acceleration. Okay, and we're going to move the t over to that side, so we're going to get that change in v is equal to acceleration times the change in time. Okay, and that will give us v final minus v initial is equal to acceleration times change in time. There we go. And these 2 equations are really the only equations you'll ever need. You have every single variable that you need to solve in order to solve any kinematical problem. Right? So let's work through this. Let's say that we know what time is, we know what the acceleration is, we know what the change in displacement was. We just want to find what the initial and what the final speed was. Okay, so all we have to do is we have 2 unknowns, v final and v initial, and we have 2 equations, so we should be able to solve. So let's work through this. Let's first start by finding v final. Okay, So we're going to take this equation, equation 2, and we're going to rearrange it so that v final is equal to acceleration times the change in time plus initial speed. Okay, there we go. We've one step isolated for vf. Okay, and now we're going to plug this into equation 1. So change in x is equal to 1/2 times v final, which is that. So acceleration time plus vi times change in time, which is equal to 1/2. Okay, vi plus vi is 2vi divided by 2 is just 1. So this will just be vi, okay, plus 1/2 at times t, so 1/2 a t squared. Okay, that's delta x. Okay, so in other words, vi is equal to delta x minus 1/2 a delta t squared. Oops, sorry about the box. There we go. Okay, and now all we have to do is sub this back into this equation to find vf. Okay, so we're going to move that back here. So vf is equal to a delta t plus delta x minus 1/2 a delta t squared. Okay, and if we knew what all these variables were, the numbers, we just have to plug that into our calculators and we can find what we're looking for. So that's there you have it, the simplest kinematical explanation. Okay, these equations are simple to use, just you have to use them rightly and know how to rearrange and find what you need. Okay, that's it, very simple. Thank you.